Okay, this lesson is on polynomials. A polynomial is a term or finite sum of terms in which all variables have whole number exponents and no variables appear in denominators or under radicals. Here are some examples of polynomials. 3x squared minus 5x plus 1. That would be a polynomial. It has three terms. These are all examples. Another example would be 7x plus 2. That is a polynomial which has only two terms. 4a squared b minus 6ab squared plus 5a. That is another polynomial with three terms. And you can even have something like 4x squared. That is also a polynomial, and that is only one term. So these are all examples of polynomials. All the variables have whole number exponents. Now here are some examples of expressions which are not polynomials. Not polynomials. Three x squared plus 2x to the negative 3. The 3x squared is fine, but you cannot have a negative exponent in a polynomial. So because of this fact right here, this would be no, not a polynomial. Nine minus 3 square root x. You cannot have a variable under a radical in a polynomial. So because of this, this expression is not considered a polynomial. 5x cubed minus 4 over x plus 1. You cannot have a variable in the denominator of a fraction, for instance right there, and so this one is also not a polynomial. So these are all examples of not polynomials. Now usually we want to write a polynomial in what's called descending order. That is where we write the highest power first and then we decrease as we go from left to right. For example, negative 4 plus 9y plus y cubed. If I write that in descending order, I'd write the y cubed first. Y cubed, then the 9y, which is really to the first power there, and then minus 4 is last. And so I've written it in descending order. Here's another one. Descending order. Negative 12 m to the 10th plus 8 m to the 9th plus 10 m to the 12th. Okay, the highest power is the 12 here, and so I would write this term first. 10 m to the 12th goes first. Then the next one in order would be the 10 here, minus 12 m to the 10th power, and then finally the 9th power, 8 m to the 9th. And there's our polynomial in descending order. Now, there are some special names for polynomials, depending on the number of terms they have. If a polynomial has only one term, for example, 5x is a polynomial that only consists of one term, then we call that, this is the name here, that is called a monomial. If we have two terms, for example, the polynomial 3x squared minus 1 has exactly two terms. here and here. And that is called, when it has two terms, that is called a binomial. Three terms. An example of a polynomial with three terms would be 2x cubed plus x minus 5. And a polynomial with three terms is called a trinomial. But all of these are still considered polynomials. After three terms, they don't have really any special name to them. We just call them polynomials. How to find the degree of a polynomial? Let's take, for example, the polynomial 9x squared minus 5x plus 3. Now this is a polynomial in only one variable. All we have is an x. And so the degree of the polynomial is the highest power for any of the for all the terms. And the highest power here is a 2. And so this polynomial is considered degree 2. (17m to the 7th) or yeah, 17m to the 7th minus 4m cubed plus 5m to the 5th. Okay, that's another polynomial. This is degree 7, this one is degree 3, this one is degree 5, and so we go with the largest one. The largest degree is the degree of the entire polynomial, and so our polynomial here is degree 7. Here's another one. Four y to the 5th minus 2y squared plus y. This term is degree 1, this term is degree 2, and this term is degree 5, and we've always got the highest power here, and so the polynomial is considered degree 5. Now, if you have more than one type of variable, then it's a little bit more complicated than this. For example, if we have the monomial 3x squared y to the 5th, I have two variables here, x and y. The degree is the sum of the exponents on the variables. So 2 plus 5 is 7. This polynomial, this monomial is considered degree 7. Here's another example of that. 13xy to the 4th plus x cubed y to the 9th plus 7xy. If I add the exponents on this in this term, those add up to a 2. So that term is degree 2. Adding those up, I get 12. This term is degree 12. And adding these exponents, that's a 1 and a 4 here, that's degree 5. The polynomial is the highest degree, and so we have to go with 12. This polynomial is degree 12. Now, we now need to know how to add and subtract polynomials. Let's back up here. Adding polynomials. All we do is we add our like terms. Very simple. For example, if I want to add the polynomial 12y squared minus 7y plus 9 to the polynomial negative 4y squared minus 11y plus 5, I simply add my like terms. I got 12y squared here minus 4y squared. That gives me 8y squared. Negative 7y minus 11y is negative 18y. Plus 9 plus 5 is plus 14. And that's how we add polynomials. Subtracting polynomials is pretty much the same. For example, 6m squared minus 8m plus 5, and I want to subtract 5m squared plus 7m minus 1. Now when subtracting polynomials, you just have to be careful to distribute the negative sign into the parentheses here like that. So this now is 6m squared minus 8m plus 5 minus 5m squared minus the 7m, and this is now plus 1. Combine our like terms. 6m squared minus 5m squared is 1m squared. Negative 8m and negative 7m is negative 15m. And then plus 5 and plus 1 is plus 6. And there is our result. Here's one more of those. Subtract. Six y cubed minus 2y plus 5 minus 2y cubed minus y squared plus 4y minus 1. Okay, so once again I have to distribute the negative sign, do everything in the parentheses, which then would give me 6y cubed minus 2y plus 5 minus 2y cubed plus y squared minus 4y plus 1. Combine your like terms. 6y cubed minus 2y cubed is 4y cubed. I only have one y squared, so I just have to write that in there. Notice, by the way, I'm putting my answer in descending order. Negative 2y and negative 4y is negative 6y, and then the plus 5 plus 1 is plus 6. And there is my result. Okay, and that is our short lesson on polynomials. In the next section or two, we'll be, instead of adding and subtracting polynomials, we'll also multiply and divide them.